Thank you so much for inviting me. I'll admit right away, I'm not a hardware guy. So I'll tell you about my research on AI safety and security, future of AI, and hopefully we'll see connections between what I talk about and what you do in your daily work, development, and research. It is an interesting topic. If you figure out that you love it and you want to learn more about it after the talk is done, you are welcome to follow me to learn more about the subject. You can follow me on Twitter, you can follow me on Facebook, just don't follow me home. That's the security aspect of it, very important, okay? Let's start. So, artificial intelligence is an interesting field. The moment we succeed at getting something done, we stop calling it AI, we call it spell checker, or we call it self-driving car. But the point I'm trying to make is we already have artificial intelligence as it was envisioned for 50 years, 60 years. All the cool things we wanted are kind of around us, whatever it is, your Google search, your smartphone assistant. Another kind of more hardware topic is robotics. We have bodies, not just brains, but very good results in developing bodies for those machines. Boston Dynamics does a great job, and it's kind of growing at about the same rate of progress. You maybe seen some of the amazing videos of Boston Dynamic robots performing really cool tricks. So what happens next is usually the question people want to know the answer to, and I will claim, and this is more controversial than the previous two slides, superintelligence is coming. What does that mean? So because of resources allocated in terms of human resources, in terms of financial resources from White House, European Union, private corporations, Facebook, Google, putting billions of dollars into the space, we are starting to think that we'll succeed at reverse engineering human brain, or at least getting to the same level of performance in AI, and we'll have artificial general intelligence. And the moment you have human level or general intelligence, very quickly you have something beyond it. You have faster speeds, you have access to all the knowledge on the internet. So essentially around the same time, you'll get something beyond human level performance. Everyone wants to know, how soon will this happen? And I'm not an expert on this type of predictions, so I trust other people to make their charts. Ray Kurzweil is famous for developing those exponential growth charts. You might have seen some of them. He basically maps on processor speeds over the years, let's say for a $1,000 laptop. And he's been doing it for decades. And he's pretty good at predicting then we're going to hit certain milestones. And the interesting ones are just starting to materialize. We're getting to the point where we have enough compute to simulate a whole human brain. And maybe in a few years, it will be not just one brain, but all the brains in this room. So his predictions were that we're going to get to this level of performance somewhere between 2023 and 2045. So we're getting fairly close to this, and the compute, I have a few charts about the actual compute available right now, is starting to be sufficient in terms of estimates we have for human brain and equivalent performance. One of the most recent developments in the field of AI, neural networks, deep neural networks, is this idea of scaling hypothesis. If only we could get to some sort of architecture which allows us to keep improving by simply adding more compute, more data, without having to redesign the architecture, then essentially that's enough to get us to human-level performance. And from what we see, we are at that point. So we can estimate exactly when and how we're going to get to that level. If you read Hitchhiker's Guide to the Galaxy, you know the question, what is the meaning of everything, universe? And the answer is 42. Well, one of the founders of kind of modern DeepMind revolution joked that the answer is really 4.398 trillion parameters. Once we get to a model of that size, that will contain all the knowledge of our civilization and be able to perform at the level of any engineer or scientist. So definitely interesting times to be alive. Here's more of the available compute. I pulled this chart from top 500 supercomputers. So this is not a $1,000 laptop. This is the best they have. And the data is about a year old. I think it's November of 2021. So there is already another #1 system at the top of the chart. I think it's still being deployed. But we're getting to exaflop level performance. And this is what we were hoping to get in order to be able to simulate brain and silicon. And again, the dates kind of match up, 2023, around that range. It may take us a little longer to get there, but I don't think it's going to make much of a difference in terms of what else I'm going to tell you about today. And we also can look at not just human level performance, but also for self-driving cars. What amount of compute do we need to process all the sensory data at different levels of autonomy? And likewise, we're seeing similar levels of accomplishment. We're getting there, so that's another milestone we're likely to hit. So we find ourselves in this interesting situation. Right now, we are still smarter in many domains than any AI, any computer. But I think because of progress we see in computing, because of a hypothesis that we can scale with nothing but compute, this is about to flip. And we are not going to be the smartest thing around in the future. And what I want to do is kind of assume that, well, maybe it's true, we'll get there. Let's try to predict some of the features, some of the properties of those systems. So one, and that was kind of foreshadowed a bit in an introductory talk, is those systems are super smart. And we see it in narrow domains, like protein folding, like playing chess, like playing Go. A lot of those narrow domains have been completely dominated by machines. And the moment machines dominate, there is no reversing this trend. We're never going to have another chess player, world champion, who's biological, who's a human. And what we expect is that not only is this going to be true for narrow domains, it will be true in general for all domains, including such domains as science and engineering, where you can now apply that AI capability to design the next generation of AI chips, compute, and so you'll have this self-feeding loop of progress. Another capability, another property of those systems is their complexity. So this is a picture of an instrument panel on a modern airplane. This is kind of a GUI interface. You don't see all the code behind it, millions of lines of code. And the pilots, even experienced pilots, usually don't get a chance to exercise all the code behind their system. This is already leading to some accidents. We had problems where there was misunderstanding, miscommunication between the autopilot and pilots, sometimes caused by sensory malfunction, sometimes not. But the point is, the complexity of those systems is likewise growing exponentially. Another issue is speed of those systems. We know that computers are fast. That's not what I have in mind here. I'm talking about ultra-fast extreme events where machines can change your environment so quickly that you won't even realize something happened. An example I frequently use is the stock market. We had examples where it would bring down the stock market, return it back to its original value, billions of dollars of wealth wiped and then returned. And it happens in amounts of time where you cannot monetize that opportunity. You cannot react to it live. But we'll expect similar events to happen in other domains beyond just the stock market. So we, of course, would not be dumb enough to surrender control to machines, right? Especially before we even got to super intelligent performance. But we kind of did. If you look at the stock market, most of the trades are done by bots. Whatever it's high-frequency trading or just normal trading, over 85% of it is automated. Nuclear power, electrical grid, all the cyber infrastructure is controlled by machines already. And again, this is AIs of today and yesterday, not future AIs. So in terms of who is kind of in charge of infrastructure, we already know the answer to that question. My background is more in cybersecurity. I run the cybersecurity lab, so I'm very interested in the intersection between AI and bad guys, malevolent actors. If we look at computer viruses, we see steady proliferation of infections, not surprising. More people have devices, more people use AI in those devices. But all cybersecurity experts know that the easiest way to hack any system is social engineering. You attack the human, not the system. And with that human-level AI, such types of attacks become very easy to do. I'll talk about deepfakes a little more, and basically opportunities you now have to attack millions of different accounts simultaneously by creating targeted phishing attacks. Used to take a lot of effort. You had to study someone's social media, tailor just the right message for them. Now you can do it at scale, and so you can get millions, if not billions, of accounts attacked at the same time. There is also research, mostly funded by the military, by DARPA, on developing robot soldiers. There is a good angle to it in terms of rescue robotics, but a lot of it is how do we create autonomous drones, autonomous soldiers, which are very good at killing their targets, and those targets are sometimes humans, or always humans. I don't want you to think that I am this very negative, pessimistic guy. AI is amazing, and there is a lot of potential for successfully using this technology if we do it right. AI can help us with science, with engineering development. It can help us with medical research. We can cure a lot of diseases. Protein folding is a great step in that direction, predicting protein folding. We can get free labor, both physical and cognitive, once we're at human-level performance. So you're talking about trillions of dollars of economic growth. Maybe immortality may be possible if we fully understand human genome. There is a lot I can't even predict of what is possible. The unknown unknowns. I'm not super intelligent, despite what they told you, otherwise or not. But there are things we cannot anticipate until we get to that level of performance in a good direction. Sadly, for each one of those positive outcomes we anticipate, there is a complementary negative outcome. If you have free labor, you'll get technological unemployment. If you have rescue robotics really well developed, you have military robots. And again, you have this unknown unknowns option where you can get really bad things and we cannot predict them in advance. We will be surprised by them. A lot of it was complete science fiction a decade ago. Then I started this type of research. I was told not to kind of go in that direction. It will not work out well. But since then, because of progress in AI, more and more people are starting to realize that this is something to at least look at. We are concerned about safety and security in this domain. And some famous people, rich people, very successful people expressed concerns about even current state of AI, but more so about future possibilities in that space. So what are they specifically concerned about? It is not the Terminator movie scenario where you have this Arnold Schwarzenegger character chasing humans. The concern is that we humans typically consider us very different, very diverse, very unique. We come from different cultures, different genders, different preferences. But if you think about it, we're almost identical in terms of our brain design, DNA. We like very similar temperatures. We consume very similar foods. If you look at all the humans together, the mind design space of humans, we have this tiny pale blue dot there, right? If you consider a space of possible intelligences, so think animal intelligences, think aliens, if you believe in aliens, alien robots, and different types of AIs would have very different preferences, values, algorithms for making decisions. And if they are not aligned with our preferences and values, this is where the problem would be expected to happen. I call it the singularity paradox. You have those super smart, super intelligent machines, but they're too dumb to have common sense a child is expected to have. And so this is my area of research. I look at how we can get in trouble with AI. Whatever it's pre-deployment stage, after deployment. Of course, you have all the problems you expect in software development. You have bugs in code, mistakes in design, bias in data. But there are some unique problems we expect as well. Problems with self-improvement. If a system is capable of rewriting its own code, that's somewhat different from what we used to in terms of our ability to verify such software. And there is also problems with, which are not unique to AI, but problems with malevolent design. It's the same people who write computer viruses today, they look at AI and go, you know, I can just add my own goals to this, and now I have a malevolent system with a malevolent payload. Just like with viruses, you still can make mistakes. You can, are they coming after me? We can still make mistakes in coding the system. We can still put wrong goals into the system, but now you have this additional malevolent payload, and it's strictly worse. And the problem is we have almost no research in how to deal with this type of activity. You have insider threat, you have someone from outside the system who can get access to the code, maybe blackmail or bribe developers into providing them access. How do you prevent something like that? I think so far we had like one workshop on this topic. Maybe there is like one paper, but that's a very serious problem to be concerned with. So what is all this kind of put together? This is the domain of AI safety and security research. Science and engineering aimed at creating safe and secure machines. We want AI to be safe in its performance towards its human users, and we want the system to be secure from outsiders, from hackers, from manipulation. So that's kind of the general field, and it includes both short-term timeline safety for existing AI and trying to predict, anticipate, and make future AI systems safer. So I don't want to limit my talk just to future. I want to tell you about some of the existing problems we have right now, but that should give you kind of some idea about how fast this is progressing. So this is deepfakes. I said I'll mention it a little more. I want to tell you about capability growth, this exponential chart. You see it, but it doesn't kind of speak to a person, right? We're visual animals. We need to understand how it works. In 2014, we learned how to generate those face-looking like images. They were tiny, low resolution, black and white. Next year, we knew how to do it in color. They still looked kind of freaky, right? The eyes wouldn't align, and it was, at the time, we felt it was amazing. But now, you can see this progress. So around 2018, I would say, we got to where it looks like a human. We can now fool people with those fake profiles, and we didn't stop there. We kept developing, and now you can, with a few phrases, describe the picture you want, change it, make it super high resolution. It's kind of cool. It's a fun thing to play with, but why I'm interested in this from security point of view? In the left upper corner, you have this dog-cat mixed picture. Can you see it well? So what we can do is we can create adversarial images, not just for machines, which are well known, but also for humans, kind of like optical illusions. We can take a picture of something, modify a few pixels in it, and a human will perceive it as a completely different type of object. What happens then we get this level of progress, as we saw in face generation, with those adversarial images? Right? Maybe they would be movies, maybe sounds, but similar type of attack on human visual system. So just something to think about. Another kind of existing set of problems, current neural networks, right? If you work with them, you know they have a number of problems in terms of how they perform. If you're interested, I pulled this data from 2 papers, very technical, very kind of hard to understand right away. They give scientific sounding names to problems which I think we all encountered. We are biological neural networks. Artificial neural networks are somewhat inspired by how we work and what we do. And children, some of you, I assume, have children. I say they're untrained neural networks deployed on real data, right? The problems we see with kids are the same problems we now see with those neural networks. We just give them more appropriate scientific names. So think about something like, I'm not going to go through all of them. It's a lot of technical jargon. If you're interested, definitely read the papers. But something like avoiding reward hacking is a desire of people developing neural networks. But if you think about it, it's the situation where your child gets access to the cookie jar, right? That's essentially what happens. You reward them for good behavior. They go, I don't need you, I'll find the jar. And we can anticipate a lot of it through just studying human psychology, developmental psychology. So that's very interesting that we're already at the level where the problems we encounter with human biological neural networks are showing up in those artificial neural networks, and I predict we'll see a lot more of that. Another existing set of issues in the domain of safety or ethics is with self-driving cars. I think many of you probably seen this study, maybe. It's the famous trolley problem, but scaled up to millions of users across many countries. And the goal is to decide, okay, we need to program self-driving cars to be safe. We want to tell them what to do in split-second decision situations. Humans usually don't encounter that problem. We're too slow and dumb. We just do something and hope it didn't kill too many people. A very smart self-driving car will have enough compute to decide what is the optimal course of action in the next second. And what they do is they create scenarios. Okay, your brakes are out. You have to go left or right. That's the only option. So somebody's going to get killed. But do you kill 4 people or 3 cats? Old or young, rich or poor, criminal or... I think the only lesson from this slide is that you don't want to be a criminal cat. That's the worst thing you can be. They'll definitely kill you. But other than that, you have to make decisions, and those are culturally different. Different countries have slightly different preferences. Do you protect the driver? Do you protect the pedestrians? Do you protect, and you can see what degree of difference overall averaged out is. So whoever is breaking the law, criminals are usually more likely to be killed. People have some preference for younger people. So if you have a choice between baby and a 120-year-old, baby gets preference, and so on. But this is not universal, so you have to figure out, is this car going to be region-specific? Do you switch regions when you move countries? Do you hack it so it protects the driver and you don't care what the government says? So those are very interesting, existing ethical questions some of you may be actually struggling with today based on your research. Overall, this is part of a bigger AI control problem. So again, not limiting it to narrow systems of today. If we look at the general problem of can we remain safely in control in a world populated by superintelligent systems? Can we benefit from them, but somehow not be sidestepped? And no one knows the answer. There is not a definitive answer. There is not a proof to that. It could be that the problem is not even solvable. Maybe it's not meaningful to ask this question. So this is a big part of what I'm trying to do, trying to clarify this. There are different types of control we can anticipate. I'll talk about the extremes, but anything in the middle is kind of a hybrid combination of the two. Explicit control is where you give orders. You say, do something, and the system has to do it precisely. This is the famous genie problem. You have a wish, you make that wish, and then you regret it, and you use your next wish to undo the damage. Right? Because the system is not using common sense to interpret what you want. It just does what you said. Kind of like when you're programming and you get bugs, it's because the system did exactly what you told it to do. The other extreme is delegated control. The system is super intelligent, you're not, you go, I trust you, you figure out what's good for me. You make all the decisions. It may be okay, but you're definitely not in control in that scenario. And the two others, implicit and aligned, are kind of like mixed bag. It may trust you a little and ask for your opinion, or it just kind of looks out for extreme cases. So we have this scenario where we need to decide how much autonomy, how much independence, versus how much control and safety we want in the system. And trade-offs are definitely necessary, but we're not sure exactly where to place that equilibrium point. What I realized is that if we successfully solve control problem, there is a good chance we'll need a set of tools for doing it. We need to be able to explain how the system works, predict its behavior, verify that the code we wrote matches the design. There is quite a few others related to governing the systems properly, communicating with them. I'm not going to go through all those, but the point I'll try to make is that for each one of those required tools, where we have well-known, established proofs saying some versions of this are impossible. We can never get to that level. So if we look at something like explainability, we want to understand how a deep neural network with thousands of parameters, weights, makes a decision. And I have a paper where I basically show that you're going to get one of two outcomes. Either you get a simplified, dumbed-down answer, which is not really true. It's like a kid asking you, where do babies come from? And you say, we bought you in a store. That's what you get. Or you'll get a precise answer, which is essentially equivalent to the whole model, so you will not comprehend it. So sometimes when you want to dismiss a student who's asking too many silly questions, you give them very technical response and they go away. That's kind of what humanity will be dealing with. So that's just one example with explainability tool, but there are similar limitations for all the other tools. I removed them for time constraint limits. Another very desirable property is bias and debiasing. We want our systems to be fair, treat everyone well, and we understand that the data we use is human-generated, and it's full of bias from local culture, whatever it is, gender bias, sex bias, racial bias. The problem here is that under certain realistic assumptions about the world, such as you don't have a perfect classifier and different subsets have actually different features, there are multiple proofs showing that you cannot completely remove all bias. So that's also something to keep in mind in terms of existing issues with narrow AIs we're already working with. So what can we do and what's happening? The good news is there is some realization this is a problem. There are good books coming out addressing this issue. Nick Bostrom wrote a book on superintelligence, which was a New York Times bestseller. Any of you seen it, read it? Heard about it? Can hear me right now? Not asleep. Okay, we're getting some traction. That's great. I have a few books on those topics. You can find them online as a PDF for free, I'm sure, if you're smart enough. They will give you a great, much more in detail intro to this topic. In addition to some books, there is now a lot of organizations set up to deal with this problem. All top universities, MIT, Harvard, Cambridge, so on, have now a safety lab. There are startups in this space, Anthropic, Conjecture, Aligned AI, Redwood Research, all trying to understand how we can solve this problem, what we can do. Me and a colleague, we wanted to understand what people have suggested in the past to deal with this. And we surveyed about 300 different references we could find on this topic. We classified them, we grouped them. I'll give you a flavor for what people have suggested for controlling machines. I want to point out that earliest reference we found was from 1863. So in 1863, someone went, machines are getting out of hand. We need to control them, and here's what we do. It's like a meaningful contribution to that. All right, so what do people suggest we do? That's the first one. I don't have a picture for it. The idea is that if machines are that smart, they'll be nice to us because smart people are always nice. Yeah, problem with this approach is very hard to get funding for it. I tried. But also there is a small chance that it will not work out, and we need a backup plan. We need to really make sure we're doing it right. Another solution. Anyone recognize this guy? Professor Kaczynski? Yeah. He took this problem so seriously, he said, let's kill computer scientists. As a computer scientist, I have a problem with this approach. I think it's not optimal. It's starting to be available from the military, yes. So relinquishing technology might actually work, but it doesn't work in terms of limiting damage. If we give up on good AI, we give up on all the progress, medical breakthroughs, scientific breakthroughs, economic value. So it's unlikely to be a meaningful solution, but some people did suggest certain moratoriums, limits on how quickly we progress in this space. Another idea is to integrate machines with society. So give them laws, rules, text them, and then they can just participate with the rest of us. There are certain problems with this approach as well. How do you punish an AI? How do you send it to prison? How do you deal with it in the same meaningful sense we deal with human criminals? So that's unlikely to work, in my opinion. What may work, but has its own problems, is saying, okay, they're going to be super intelligent. We're going to compete with them. We're going to improve humans. Maybe we'll have brain-computer interfaces. Maybe we'll do uploads. Elon Musk is working on what he calls neural lace, implementing this interface. So essentially, you'll become a program on a computer somewhere running at much higher speeds. So now you are super intelligent as well. It's cool, it might work. Problem is, you are not a human anymore. You are now one of the programs on a computer, right? So maybe that's not a solution we're looking for. The most famous set of solutions comes from Isaac Asimov's 3 Laws of Robotics. I'm sure all of you read the books, seen the movie, at least, yeah. What you can notice from the books is they never work. Those are literary tools to write really awesome books. They always fail. They are self-contradictory, they are ill-defined, and if you increase the number of rules to 4 or 10 or whatever, it still doesn't work. So those are not solutions. Unfortunately, culturally, we think that this is the solution to controlling AI, and it's not a good one. So if you remember anything from my presentation today, remember that. 3 laws don't work in practice. What are some promising things we can do? Verification of software and validation is something we know how to do for mission-critical systems. We're good at that. It's expensive, but we can prove certain small pieces of software as be absolutely correct. We don't know how to do it for self-improving software, learning continuously in new domains, making decisions which we don't know ahead of time. So it's an open area of research. If it's something you might be interested in, definitely there is interest in that. Another area of interest is essentially creating tools for making it possible for developers to better test their software. So sometimes we just call it AI prison. We want environments similar to what we do when we test computer viruses, separated from the internet, air-gapped, limited communication channels, so we can study what knowledge it has, where it communicates to. This is also supposed to limit social engineering attacks. How many of you seen Ex Machina movie? So we want to make sure that is limited. Again, a very limited area of successful applications so far. There is some projects in terms of creating virtual environments for testing AIs, but more can be done. And essentially, we want to understand what is ethical in this domain and what is not. It seems like everyone agrees that narrow AI research, making calculators and text software, is absolutely ethical. Making something which is uncontrolled, unpredictable, unexplainable, maybe less so, and it's still an open area of research in terms of what we can do in terms of governing this type of work. There are suggestions, real proposals from real researchers about limiting access to compute to slow down or control development of new models. There is proposals for ethics boards, and they've been implemented. We had a paper on this topic, and I think Google had an ethics board for a while. A few other companies did that. So yeah, it's not obvious that the research being done is actually beneficial to humanity, and we want to make sure that it is in fact the case. So in conclusion, I want to tell you about another project I had where we collected all the historical accidents and failures in AI we could find. I give you a few examples from early on till about 2016. There is 2 other papers providing a lot more examples, and this was basis for partnership on AI's database of accidents, which has well over 300 now. And you can see that there is exponential growth in accidents. Obviously, we have more devices, more software, impact is growing. And what I want you to do is to think how that applies to your project, to your work, the services and products you develop. Usually by studying a lot of those, your neural network can kind of discern a pattern and predict how your system may fail. So if maybe you're using AI to completely autonomously design a new chip, what can possibly be wrong with that? How it can backfire, what problems you can anticipate and fix ahead of time. So this is what I hope is the application to your specific domain from this. But overall, I think it's important to know you will be, whatever you agree to it or not, subject to this new technology. It will be deployed and impact your life, impact future career choices for your children, impact your investment plans. So I definitely encourage you to at least be aware of latest developments in this field. If you want to learn more, there is lots of papers you can get through Google Scholar, again, books, and I'll leave lots of room for questions. I'm very happy to have an interactive conversation about this. Thank you.